Hey gang, this is Mr. E, and we're going to start with Chapter 1, which is talking about the introduction to physics. Now, before you get into what science is today, you have to understand what science was before we learned how to actually do it, how it exists today. Um, we used to use only logic. Now, that may sound perfectly well and good. Logic is pretty useful. But the problem is that you get into justifications, you get into common sense, which a lot of times is not correct. Sometimes it is, but a lot of times it's not. For example, Aristotle used logic, okay, all the time. Brilliant, brilliant person. But he said that, for example, that men eat more food than women, right? So therefore, they have more teeth than women. Women have fewer teeth. Now, it never occurred to him to go and test this idea. It was just all based upon logic or common sense. And unfortunately, that was wrong. So we now know in order to get the true answers, we can't use common sense alone. We cannot use logic alone. We have to use tests and experiments to get at the truth. So, what is the definition of physics? Well, a definition of physics is something that needs to include concepts that are subatomic particles, really tiny things. And I'm not talking about just atoms that you might have learned in chemistry class or some previous science class. I'm talking about what makes up the protons, what makes up the neutrons, and what is an electron, and what are baryons and gluons and leptons and things like that. So those subatomic things, what are they? And then what are big, big things like the galaxies and what holds those galaxies together? So our definition of physics needs to include that huge range of concepts. Now, a misconception of physics is that it's all about solving word problems or memorizing equations and doing a bunch of math. Now, don't get me wrong, math is extremely important and when it comes to finding out concepts within physics. But that is not the whole thing. That is just a tool that we use to help make it unambiguous. So what is physics? Here's the definition that we're going to use. It's a branch of science that studies matter and energy and then how they interact, how the matter and energy interact. It's pretty broad, I know. There's branches of physics that we will get into as we go through our course, and a lot of times it's broken up into those sections. You have mechanics and you have electricity and sound and waves and so forth and so on. So we can break it up into more detail, but physics covers all of that. All right, let's watch this video here.
The question is, if you get a cloth dripping wet without gravity and you wring it out, what's going to happen? What will happen to a wrung out cloth? So, and I had to use equipment that was here on board the space station. We may have the coolest washcloths ever here on the space station. I'm going to show you. Here's one of our washcloths. And it's compacted. It's put down into this little tiny hockey puck so that it saves space. But when you open up a hockey puck and you pull out your washcloth, this is the one I'm going to use for the experiment today. And so when you open up your hockey puck and turn it into a washcloth, it was compressed in a great big vise somewhere. Okay, so here's my washcloth, like a magic trick. And now I'm going to get this soaking wet, and then we're going to see what will happen when we wring it out. Meredith and Kendra suggested that I dip this in a bag, but bags don't hold water in space, so instead I filled a water bag. This has drinking water in it. And I'm going to squirt a bunch of water into this washcloth. Okay, so here's a soaking wet washcloth. Get the microphone so you can hear me while I'm talking. And now let's start wringing it out. It's really wet. It's becoming a tube of water. The water's all over my hands, in fact. It wrings out of the cloth into my hands. And if I let go of the cloth carefully, the water sort of has it stick to my hand. Okay, so the experiment worked beautifully. And the answer to the question is the water squeezes out of the cloth, and then because of the surface tension of the water, it actually runs along the surface of the cloth and then up into my hand, almost like you had Jell-O on your hands or gel on your hand, and it'll just stay there. Wonderful moisturizer on my hands. And the cloth doesn't really unravel itself. It just stays there floating like a dog's chew toy, soaking wet. Great experiment, worked perfectly. Meredith and Kendra, congratulations, great idea.
Okay, gang, let's go ahead and end it here. This is just 1.1, real quick video. We'll go into 1.2